Okay, so here we are for 4.4. So once again, if you watched Matt's and you got it, you can disregard this video. But if you feel like you need more remediation or review, then tune in and we're going to go over 4.4. Okay, so first of all, we're going to start off here and we see that we have two chords intersecting inside the circle. It says consider the intersecting chords DC and EF that intersect at point B. So it's easy to see. Point B has broken our chords into two parts. Now, not congruent parts, but into two parts. So here we see that DC is broken into Y1, Y2, and then EF is broken into X1 and X2. Now, draw an auxiliary line segment DE and CF and create triangle DBE and triangle FBC. We know that the measure of DEB is congruent to FCB because they are both inscribed angles that intercept at the same arc. Okay, so they're both intercepting the same arc up here. They're inscribed angles, so therefore they have to be the same. So that's arc FD. Also, we know that angle EDB and CFB are the same because of the same reason. And so we know by AA that triangle DBE, angle, triangle DBE is similar to triangle FBC. Okay, so not congruent, but they're similar by angle. Okay, so now if we come over here, we can say, using proportions of similar triangles, we can say that x1 over y2 is equal to y1 over x2. We can cross multiply to give us this following statement, that x1 times x2 is equal to y1, y2, because they're all in proportions. So from that, we can conclude that if two chords intersect, then the product of the measures of the two subdivided parts of one chord are equal to the product of the two parts of the other chord. So basically, if we look here at number one, we've got one chord and we see that one part chord ED, that FE is X and EF is 8. We also have chord BC in which BF is 7 and FC is 10. So therefore, all we have to do is say 7 times 10 is equal to X times 8. Just make your equation there. 70 is equal to 8x and divide by 8 and you get 8.75. Okay, so now we're going to come over here to the next one. We have chord BC, which is FX, and chord ED, which is 6 and 6. So 4 times x equals 36. Solve, divide by 4, and x equals 9. Okay, so far pretty simple. Now we're going to jump down to number 3, which here in this one, we have chord DE, which is broken up into just XX. Now it's two congruent segments, so it is divided in half, but we don't know what the measure is. It's just saying X. Now BC is broken into two segments of 2 and 8. So we're simply just going to say 2 times 8 equals X times X, in which we get 16 equals X squared. Except we want to solve for X, not X squared. So we simply just take the square root and X is equal to 4. Okay, so then we jump over to number 4. And we see here that we have chord DE, which is broken into X and B. Okay, and then we also have another chord, BC, which is broken into 6 and 4. We also have a triangle that is being made from CFE because of line or chord EC, which is 25. So that makes it possible for us to solve for B by using the Pythagorean theorem. So the first thing we're going to do is use the Pythagorean theorem by saying a squared plus b squared equals c squared. We have a and b, which is, well, we have a and c, which is 24 and 25. We have to solve for b. So basically, we're just going to square that 24 to get 576 plus b squared is equal to the square of 25, which is 625. Now to solve for b squared, we simply subtract 576 from both sides to get b squared equals 49. And then lastly, take the square root of b squared, which is equal to 7. So b equals 7. Okay, so now numbers 5 and 6. It says find the most appropriate value for x in the diagrams below. So here we see we have chord BC, which is x plus 3 and x, and chord ED, which is 4 and 10. So we're going to multiply the x squared, or the x times x plus 3, and the 4 times 10, and we get x squared plus 3x equals 40. All right, so we have a quadratic here. Now you got to pull back to Unit 3 of Algebra 1 to remember how to do this. But we're going to solve this here by using factoring, which means we have to make the equation equal 0, and we accomplish that by subtracting 40 from both sides. Now we have x squared plus 3x equals negative 40. So I see my sign is a negative, so I'm going to need a negative and a positive. We know negative 5 times positive 8 is negative 40, and then negative 5 plus 8 is negative 3. So we will factor this into x minus 5 and x plus 8 equals 0. Next, we have to take that x minus 5 equals 0 and the x plus 8 equals 0 and solve for x. And we will get that x is equal to 5 and x equals negative 8. Now, because we know that x cannot be negative, this chord right here cannot be a negative, that makes our negative 8 an extraneous solution, meaning it's just not, we just can't use it. So now we're going to take that x equals 5 and we're going to use that, and that will be my answer.